Well, welcome to good old wintry Christchurch. Don't be fooled by the sunshine because it was snowing just before. Hope you've got your winty willies and you're all prepared for a big day on the geospatial field trip. This is Steve Boonsberg and he's from Land Information New Zealand, LINZ, and he's brought you to this rather shabby looking area in Bexley. This area has actually been red zoned, so they're not allowed to build here again. But to know that, they had to test the land. Steve, how did they go about testing these sections?
Well, what happened after the earthquakes when we saw all the liquefaction, we realised that we needed to know a lot more about the ground conditions. So what happened was EQC and the government and CERA undertook a program of CPT testing. That's cone penetration testing. And what they had was they had a special rig on the back of a truck, and that would push into the ground and measure the resistance and the strength of the ground. The other type of testing they did was taking bore samples, where they would bore a hole into the ground. It's like a massive drill, and they drill down into the ground, and then they look at the material that comes out of the ground, whether it's stones or sand or silt. And they take both of those results and they do calculations, and they calculate how strong the ground is and how resistant it is to future liquefaction. And we have a couple of maps here that actually show that. This top map, all in yellow, shows where liquefaction occurred after the February 2011 earthquake. And as you could see, it was quite extensive over the whole city. It didn't mean that every single area here had liquefaction, but generally these areas experienced damage.
So, liquefaction, remind us, what is that and why has such a large area of Christchurch experienced it?
Liquefaction is a process where the ground is shaken to such a point that it becomes a liquid. Instead of operating like a solid piece of dirt, it actually becomes a liquid. And the way that happens is as we know, under the ground is groundwater. And under the pulses of the earthquake, the water surrounds all of the particles so that the sand or the silt is completely surrounded by water, and it acts like a liquid. One way that you might understand this is if you remember going to the beach and you walk down to where it's very, very soggy and wet. If you jiggle your foot in the sand, then the sand will flow up and over your foot. That's liquefaction.
Yeah, certainly not something you want to build on. So the information that was gained by this testing, how's that actually shared?
A number of studies have been done to understand the liquefaction risk. This map here shows a potential liquefaction map for a study from the University of Canterbury. Other things have also been done, which is looking at building damage and understanding the relationship between how buildings were damaged and what the ground conditions were like. So with all of this information that's been looked at, the government has come up with new guidelines on how to build on liquefaction land. If land is really highly prone to liquefaction, that land has been what we call red zoned and is unable to be built on. Other land has been classified as TC1, which means no liquefaction potential, TC2, which is mild, or TC3, which is quite a severe liquefaction risk. And in order to build on that land, a number of things has to be done. If it's TC3 land, then the land has to be strengthened through groundworks, which is like compacting the ground or digging it out and replacing it with better ground conditions. And then depending on those ground conditions, particular foundation designs are required.
So you can see how complex it is and just how all this geospatial data can be used in the rebuild.